Let's knock it out. Turn this off. There you are. ANOVA is tricky, and a lot of statisticians, I shouldn't say a lot, many statisticians don't even bother doing it. They use other non-parametric tests, some of which you'll find in your, in your searching for your exam. But ANOVA gets used enough. It's used very, very often in the social sciences, I've noticed. I remember taking a social science research class years ago. I was the only math guy in the entire class, and ANOVA was uttered more than any other phrase. All right. So first things first, you got your template in front of you? Let's knock the pieces out. What variable are we testing? Mu. What is mu? Average? Exactly, average stopping distance. Average stopping distance for the different kinds of brakes. What's your null hypothesis going to be? Or what's your research hypothesis? What are we trying to see with this test?
If full V's are better.
Right, or if they're any different than mini V's, or if they're different than cantilevers. But yeah, we're trying to see if any of the brakes are better, right? So what's the opposite of one of the brakes is better? They're all the same. So your null hypothesis is going to look vaguely familiar to two averages. The average braking distance for cantilevers is the same as the average braking distance for mini V's, which is the same as the average braking distance for full V's. That's the opposite of what I want to see, right? That's the opposite of what I want to see. I want to see one of the brakes coming out being better, at least one of the brakes coming out being better, right? But that's the opposite. The opposite is you wasted your time and your money and your son's time by swapping brakes out, changing brake cables, and running this bike down the hill. Probably pissed your neighbor off too because it was his driveway. But that says they're all the same. But our belief is that at least one of them is going to be better, right? At least one's going to be better. And that, you can say this any way you want to. At least one is different. Now, according to Linda's conclusion, just based on a quick cursory glance at the box plots, it looks like two of them are better than the third. It looks like both sets of V-brakes are better than the cantilevers. So I can't tell if the full V's are better than the mini V's, just based on that cursory look. We'll come back to that. We'll come back to that. See if we actually can see that later on. But that's beyond the scope of this course. But at least give you a heads up as to how you can check that. So you got your hypotheses to test. Beautiful. Can we be wrong with any test that we do? Of course. Give me one. Give me your type 1 error for this one. Type 1 error though. Type 1 means that we said that one of them, at least one of them is better or changed. I like that better, Daniel. Type 1 is going to be a false positive, which means we're believing this when we should have believed this. So a type 1 means that we said at least one of them is different, but they're actually all the same. In other words, we get a result which kind of looks like what we got. It looks like the V's are better than the cantilevers. Maybe that's just goofy data, and as you saw from M&M's, it's quite possible to get those outliers as you mix in. That's type 1. Type 2! Yes! Saying they're all the same, when actually one of them is different. In which case you could be making a better choice for your brakes, but the test is not going to reveal that. Yeah. What's worse in your opinion? Type 1 error is worse. Tell me why, Veronica. Just out of curiosity.
Because then you're convincing the people to buy certain brakes when they don't do any good.
It's funny you said that. The way you said that reminds me of a study from the 90s. How many of you remember the study that came out, you might be too young for this, for dudes riding bikes? Nowadays, if you look at like high-performance bike seats, they're called saddles because they're bicyclists. They have to call things different, I guess. But they have these little split rails.
Oh, yeah.
Well, yes, because in the 90s, what were bikes doing to dudes?
Lowering the sperm.
Making them impotent. Lower the sperm count, I should say, right? Lower the sperm count. Or, according to my friends, making them impotent. Man, I'm going to get myself a new seat because the study was awesome. Except for the fact that the sample in the study was elite male cyclists that were spending like 15,000 miles a year on a bike. My friends were barely spending 5 miles a week on their bike in between beers.
Yeah.
But they went out and bought a $200 saddle because of that. And you made me think of that when you said making somebody go out and buy. That was a good study for elite male cyclists. A crappy study for my buddies back east, love you guys, that were just riding 5 miles a week. So, good, thank you for that. So yeah, so type 1's worse because they go buy something they don't need. Anybody say type 2 is worse? As a cyclist, I do. Because Shelby,
You wasted your time,
But-
for one.
well, I wasted my time for, okay, good. And there's a solution out there, and we missed it. Right? There is a set of brakes. Because you have to realize, when you're testing 3 things, if at least one of them is different, that means at least one of them is better. Correct? Because either 2 are down and 1 is up, or 1 is down and 2 are up. In any case, you've got at least one set of brakes that is making a difference in stopping power, and you missed it. So a false negative, right?
Yeah.
So in my event, again, I'm not sure I'd be sitting here with you today if I had those cantilever brakes on my bike yesterday. Honestly, I don't think I could have stopped like I did yesterday with those cantilevers. I would have buried the levers on the bars and slid right into that lady's car and across the hood. So, for me as a cyclist, as a bike who's been riding for 20 years, you know, God knows how many thousands of miles a year, I'm a huge proponent of a type 2 error being avoided, which means I have lower confidence to make this result different. But there's totally. Because I was in the bike lane, going the speed limit, actually going below the speed limit because I can't go 35 on that road. And it's one of those things, please don't do this. It's one of those things, Central Oregon are so nice. Whenever it was at the Empire Car Wash, person come out of that car wash making a left turn on an Empire, which is a hard turn to make, especially at 5:30 in the afternoon, which is when I was doing it. People going eastbound on Empire stopped, and I saw the hand go up. I got eyes in the back of my head and off the side of my head. I saw the hand in that car go up and go like this. And this person came out, and I saw this person coming over. So they're waving 2 people on. One out of the car wash, one into the car wash. Gotta get your gravel filled. And I'm coming down the bike lane. I have no stop sign. They don't have a stop sign. They've created a stop sign in the road because they decide that the traffic pattern needs a stop sign right there at that moment. So it's totally their fault. But, I mean, what good does that do me if I'm laying across a hood? Like, yeah, it's your fault and now I'm in a hospital bed. Like, I'm going to avoid the injury if I can and avoid the accident. So I was pissed. We had a little talk with the driver to let him know what they did wrong. It was punctuated with the slamming on their hood. Hopefully she remembers that next time she tries to cut up from traffic. And the problem is, people are being nice. How do you fault somebody for being nice? It's hard, right? They're trying to let somebody out of a turn that's going to take them 15 minutes to get out of, maybe. I mean, I've sat at that turn too, going the other direction. I've sat at the 97 with my son going to swim lessons and been late for swim lessons. But hell no, I'm not going to wave somebody on because I'm a bike commuter. And I know that you don't see me. My friend Kurt back east, same exact thing happened to him. They said he was going 50 miles an hour down a hill, and he hit a car, ended up 3 cars down in the hospital for 6 months. So this is why a type 2 error is, in my opinion, something to avoid, like the plague. Type 2 error and this stuff on the road. Let me get see you doing it, I'll chase you down. I carry a loaded water bottle on my bike at all times, and I will squirt you in the face through your open window. Just so you know, I've been warned. Anyway, okay, so we got the error analysis. This is the one and only time you will circle which distribution? F. This is the F distribution, my friends. This is the F distribution. You have to use a Dewey distribution because it's not Z, it's not T. It seems like it should be T because it's averages. But because we had to construct the test statistic as a ratio of 2 chi-squares, it's a whole bastard child of everything. It's not even chi-square, it's a bastard fusion of 2 chi-squares. All right, we're ready to go. We need a test statistic. So, grab your TIs. This is one of the messiest of all test statistics. One of the messiest of all. It's awful. It's awful. Go over to tests. Go find the one called ANOVA. It's at the bottom of mine. And then put in the lists. L1, L2, L3 separated by commas. L1, comma, L2, comma, L3. You can see an immediate problem with the TI. The maximum number of lists you are supplied with is 6. If you have more than 6 data sets, you have to augment them in some way. Trust me, if you have more than 6 data sets, you're going to have better software than a TI. So hoping God, I hope you do anyway. So cool? L1, L2, L3, enter! You're going to get all kinds of stuff back. Exactly. Shelby's like, what the hell is all this crap? Nothing is important up there except the first 2 values. The top one is the test statistic. F looks to be about 112. Is that what you guys are getting? Okay, we might, depending on data entry, some of you guys may have gotten slightly different values. But are you guys getting this? You guys matching me? If we're matching me, let's just use F equals 112 as the test statistic. That way, if you did data entry wrong, we all get the same answer and Emily's happy. F is 112. Is that close to 1? No. That's like saying I'm close to 62 feet tall. It's not close to 1, right? So it looks to me, something's off. One of those averages is off, which is driving those far away from 1. Look at that p-value. What's that p-value? If you had to sum up that p-value with a very quick word, what would you use? 0. Yes, I would call it 0. Look at it. It's 1.6 times 10 to the negative 20th. You gotta look at that. Yes, you gotta look over the. You know a p-value can't be above 100%. You've got to, sister. You've got to, and especially because technology will always do this. They have not gotten around to the point where they put .0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 Put 0. My God, it's basically 0. It's so far out in the tail, it's basically not in that curve. It's in some other curve. It's so far out in the tail, it's basically not in that curve. It's in some other curve. Yeah? Call it 0, please, Linda. Call it 0, please. Just call it 0. You can also put less than 5%. You can also put less than 5%. FYI, that's the p-value I was expecting for the M&Ms. Because that's what we usually get for the M&Ms, right there. Something like that anyway, actually even a little more extreme. So you can imagine how pleasantly surprised I was to get not that, but almost close to 100% for the p-value, right? So that's again, why my jaw was hanging down last Thursday. Oh my God. Everything else you can ignore. If you take everything else you can ignore. If you take other stat class, remember how I was showing you the construction of where that test statistic came from in Excel? Those are the pieces that are being used. The sum of squares error, the mean squares error. If you scroll down, you get all kinds of stuff. Different kinds of error. The pooled standard deviation. None of it's important. Whoops. Crap. What's important, well, you saw it. What's important is the result. The test statistic, and the p-value. So what do you think? What's your conclusion going to be, friends? It appears that there is a difference in braking distances. Could we be wrong?
Yes.
Of course. How? Type 1, small p-value. It's a tiny p-value. So, right? Type 1, small p-value. Type 1. I got a question. Which one is different? Yes, that's the trick, isn't it? That's the one downside, not just with goodness of fit, but also with ANOVA, is if you get a small p-value, you know at least one's different, but you don't know which ones. However, 244 stops right here. However, I feel terrible doing that to you. So if you're interested in the proper statistically significant inferentially correct methods for identifying which ones are different, I've got them typed up off of, I'll show you where they are. If you're interested, and you might need this in your field someday, and I hope you do actually.